Hey y'all, it's me, Miss B, and today we are talking about parabolas. So if you are to take a cone and cut it at an angle and it goes through the bottom, then you have a parabola. So, let me find the beginning here. So first let's start with the parts of a parabola. A parabola is the set of all points that are equidistant from a fixed point on a fixed line. So if I were to take this focus and kind of project it all over, it would be the same length. The standard form of a parabola that opens up or down is x minus h squared equals 4p times the quantity y minus k. And then here's a note: if p is positive, the parabola opens up, and if it's negative, then it opens down. But that's pretty common knowledge. Something we haven't talked about a ton is that if the parabola opens left or right, here's our equation: y minus k squared equals 4p x minus h. And if p is positive, it opens to the right, and if it's negative, it opens to the left. We also have this thing called the lattice rectum, which is a line segment that is parallel to the directrix, passing through the focus with the endpoints of the parabola, having a length of 4p, which should look familiar to you. So, okay, so we have these things. So this line here, that is the axis of symmetry. You've got this blue point right here. That is the focus. Here's that lattice rectum right there, the LR that goes through the focus, and its distance is 4p from here to here. That length is 4p. Then the vertex is this point right here, nothing new there. And then this line down here, this lighter purple line, that is the directrix. And its distance, this to this, those are equidistant. So those are equal distances between there, and I'll go ahead and label that. So this is equal to this. We can actually erase that there, and I'll write it up here just so it's out of the way. It's 4p. Okay. So we want to graph some parabolas now. Oh, also in our equation, notice that we have 4p, and that's the directrix, so we can just take the length of the directrix and plug it in right there. Okay, so here's what we are doing. All right, we are going to need to first get our squared expression alone, if it's not already, identify p, then we'll find the vertex, and then we'll find the focus and the directrix. And both those things happen p units away from the vertex. All right, so let's sketch the parabola. I've already got this isolated here. Let's just talk about whether it opens up or down. Because this right here is x squared, that is going to open up. So I have my x squared, so that's going to open up. And the vertex is going to be 2, 2. All right, so we need to find the length of the LR, which is given to us. It's just that 8 right there. And so that means it's 4 on each side of the focus. All right, then let's go ahead and find our P. So 4P is this right here. Oh, I don't know how I did that. So 4P is equal to 8, making P equal to 2. So my focus is going to be on that axis of symmetry 2, 2 plus 2, which is going to be 2, 4. And then the directrix is going to be 2, 2 minus, well, actually, is going to be y equals that y minus 2. So it's going to be y is equal to 0. So I'm going to graph y equals 0. That's not right. I should have done it this way. So there's the y equals 0 line. And then we have a vertex at 2, 2. We've got the focus at 2, 4. And the focus should always be inside like that. And then through the focus, we want 4 on each side. So 4 and 4 for the for those points that we're going to go through for that parabola. And then this point, oh, that is directrix. Okay, so then we have, want to graph our parabola, and we're going to have those points go through the directrix. So we don't have to plot any other points because we plotted the directrix, the focus, and the lattice rectum. All right, let's do one where we have y equals. So this one's going to open to the left because we have a negative value right here. Our vertex, so these are flipped now, so this is y minus -2.
Brooke Boland, please come to the assistant principal's office.
This is x minus 3. So we have 3, -2 as the vertex. The length of the LR is going, well, we can't have a negative value, so it's going to be +10. So I'm going to go ahead and set 4P, well, 4P equal to 10 for now. So P is equal to 2.5, which means that our focus is going to be 3 minus 2.5, since it's going to the left, -2. So 0.5, -2, and the directrix is x is equal to 3 plus 2.5, so x is equal to 5.5. So we graph the x is equal to 5.5. 1, 2, 3, 4, 5.5. So that's not quite where I want it to be. All right, so that's my directrix. X equals 5.5. My focus is going to be above that, right there. The focus is always going to be on the inside. The directrix is always going to be below it. So that's an easy check for you. And then my lattice rectum is 10, so 5 above, 1, 2, 3, 4, 5, and 5 below, 1, 2, 3, 4, 5. We can draw that parabola going through those points. Like so. Okay, we're gonna skip that last one for class. And we wanna write the standard form of the equation of a parabola with the vertex of 0. I think I had the vertex in blue before. And a focus at 0, 7.5, or 7 halves. So let's go ahead and draw just a little picture, nothing too fancy. So here's our vertex, and 0, 7 halves, so 1, 2, 3.5 is probably like right there. So this is my focus, and this is my vertex. So I'm able to see that it opens up. So I'm looking at the x minus h squared equals 4p times y minus k. All right, so x is equal to 0 and h is equal to 0 and k is equal to 0 because of this vertex right here. And then my focus is p away from there, so p is equal to 3.5, which is the 7/2. So then I'm just able to plug all that stuff into my equation. So I have x minus 0 squared equals 4 times 3.5 times y minus 0. Simplifying, I get x squared equals 14y. And that is my equation of my vertex, of my parabola. All right, here's another complete the square problem just like we did before. I'm going to separate out. This is going to be my x's and my y's. We can just kind of ignore that actually. Okay, because we only have one thing squared. So I'm going to rewrite as x squared plus 4x plus something plus 5y plus minus 6 equals 0. All right, so I need to take this number 4, divide it by 2, and square it. That's going to give me 4, which is what I'm plugging in here. If I add 4 on this side, I have to add 4 on this side as well. So I get x squared plus 4x plus 4 plus 5y minus 6 equals 4. I can rewrite this stuff right here as x plus 2 squared. There's my squared. And I'm going to go ahead and subtract 5y and add 6 to both sides. So I have x plus 2 squared equals negative 5y plus 10. If I factor out a negative 5, I have negative 5 times y minus 2 equals x plus 2 squared. So this right here gives me the equation of my parabola, and it doesn't ask for anything else, so we'll just stop there. But we would be able to find the directrix, vertex, and all that stuff from that equation.